Imagine this. A truck carrying tons of bricks drives over a bridge. The bridge does not collapse. Now imagine something else. You stand on the same bridge with just your body weight. Obviously, the bridge still does not collapse. The truck weight is huge, your body weight is small, yet engineers treat both as forces. Why does a single heavy object sometimes damage a structure while a large distributed weight does not? By the end of this video, you will understand concentrated and distributed forces. Force is simply a push or pull that changes the motion or shape of an object. Engineers must predict how structures behave to prevent failure. This knowledge allows us to design safe bridges, cranes, and buildings. Force is a vector quantity, meaning it has both magnitude and direction. In engineering, we measure force in newtons. Engineers classify forces mainly into two types: concentrated force and distributed force. Let's break them down. A concentrated force acts at a single point on a structure. We simplify real-world objects, like a machine on a floor, as point forces. Examples include a person standing on a beam or a heavy column resting on a foundation. These act at specific, localized points. Engineers represent this with a single arrow pointing at a point, often labeled with its magnitude like 10 kilonewtons. A distributed force spreads over an area or length. Instead of acting at one point, it spreads across the entire surface. Think of water pressure on a dam or the load of soil against a retaining wall. These forces act across the whole structure. A uniformly distributed load, or UDL, is equal across the entire length, like a stack of bricks spread across a slab. A uniformly varying load, or UVL, changes gradually. For example, water pressure on a dam increases as you go deeper. When force acts on a structure, it creates external movements like sliding or rotation, and internal effects like stress and strain. Internal effects happen inside the material. They are invisible but critical, creating the stress that can lead to structural failure. Remember the basic formula from Newton's law: force equals mass times acceleration. This is the foundation of structural engineering. Standard units are newtons for force and kilonewtons per meter for distributed loads on beams and slabs. Bridge designers must account for concentrated vehicle loads and the distributed load of the road surface itself. Ignoring these classifications can cause cracks or collapse. Engineering calculations protect human lives by ensuring safety standards are met. Engineers verify load capacity through physical tests, applying gradual loads and measuring how much a structure deflects. A simple misunderstanding, like treating machine legs as distributed weight instead of point loads, can lead to costly structural damage. Understanding concentrated and distributed forces is what separates great engineers. Remember, force is the flow of energy through a structure. Follow us at Concrete Hustle 01 for more engineering insights. See you in the next lesson.